All right, folks, let's jump in. Let's learn about distributing today. Okay, before we get to actual distributing, let's look a little bit at just multiplication. Now that we've brought variables in and we're dealing with terms and constants, let's see how the multiplying is going to work out there. First, look at this problem on the left. What's the sign? Not the sign, the operation. What's going on there? What's the operation? Now look at number 2. What is the operation on that guy? Are they doing the same thing or are they doing something different? That's important to note. Okay, hopefully you're telling me that the first problem is a subtraction. And then hopefully you actually decide, no, even better, it's addition, because all subtraction, we just rewrite it as addition anyway. So that's an addition problem. Whereas number 2, because we see these parentheses separating the values, parentheses tell us it's a multiplication problem. That's important to start with. We've got to differentiate what the operation is. Now on this first problem, that's addition. Those are, we think about it in terms of like and not like terms. And a P and an M are not like. So we can't add them. We're done. That's as simple as that problem's going to get. You would be told to simplify this first problem, number 1. And there's nothing to do. So that would be done. You'd have to leave it as negative 2p minus 3m. Number 2, however, as multiplication, you can always multiply terms. There is no idea of being like or unlike, okay? So this actually doesn't even matter. We don't think in terms of like or unlike terms, we just multiply. So if we did that on this first problem, negative 2p times negative 3m, first of all, I've got a pair of negatives. I would cancel those out, so it's going to become a positive answer. 2 times 3 equals 6. And then I've got variables p and m. You know what? I've got them backwards. Let's do it the right way. You want to write your variables alphabetically. It's not wrong, but it's just a good habit to get into. And m comes before p in the alphabet, so we want to write it that way. So number 2 would become 6mp, okay? You can always multiply terms together. It's a different idea than adding or subtracting where you have to think about like terms. All right, let's keep going. Let's just do a couple examples real quick of this, okay? So I'm going to multiply these together, and hopefully it's as simple as it looks. Parentheses tell me multiply. Negative 3 times 5, use our integer rules. Single negative goes to the answer, negative 15. And don't forget your variable. The x goes to the answer. Okay, second one, number 2, 2y times negative 5x. Again, 2 times negative 5, negative 10, single negative goes to the answer. And then we have an x and a y. They both get attached. Notice there's no issue of being like or unlike. The x and the y both become part of that new product, that new multiplied answer. They both just tag along and you put them on the end. Same thing on this first one, that x just tags along and becomes part of the product of that new answer. Okay, moving forward. You guys work on those right now. Pause the video, do those problems. I'll show you the answers in a sec. Let's see if you're correct. Go. All right, let's look. Right here. Right here. I've got a negative times a negative. It's going to be a positive. 3 times 8, 24. And I'm just going to bring that p along. There you go. Second one, negative times a negative cancels to a positive again. 6 times 7, 42. X, y. Simple as that. Next one. Ooh, did you multiply? Did I get you? What operation's number 3? I threw that in there. just to see if I could catch you. This is a subtraction problem. There's no parentheses, which means not subtract, but actually addition. Hopefully we're getting to the point where we think of subtraction as just undercover addition. It's just addition that we want to rewrite. So it's actually an addition problem. They are not like terms. Can't do anything. That's as far as you can take number 3. Did I catch you on that one? All right, number 4. Parentheses are back, so it's a multiplication. And there's nothing on the front of that term, or is there? There is always a coefficient. If you said 1, you're correct. That's actually 1xy. So then 1 times -4 is just -4. Now I've got 2 x's. I also wanted to throw this out and see if you guys were going to be able to track and make sure you understood. What is x times x? It's x squared. Remember, this is a different concept than when we're adding like terms. If it was an add or subtract, you would just have more x's if you started with 2 groups of x. But in multiplication, x times x is x squared. And then bring along the y. All right? Hopefully this is making sense. Let's keep going and practicing. All right, part B, distributing. First things first, what the heck does distributing mean? Let's figure out what that word means in just a minute. All right, let's do this first problem. This is exactly like what we did on the other page. -3 times 4, single negative goes to the answer, -12. Then we've got x, then we've got y. We know that when we see these parentheses right up against this first term, this -3x, it's a multiply. Okay? Now, if we apply that same idea to problem 2, we'll call that problem 1, we'll call this problem 2. What we notice is everything's exactly the same. We've got parentheses right up against the -3x. The one different thing is that inside the parentheses, instead of just the 4y, there's also a -7. Okay? But we're going to do everything exactly the same way. What we've been doing is multiplying. I'm going to draw an arrow right here. We're multiplying that -3x times the 4y that's in the parentheses. Well, if they expanded out the parentheses, couldn't we do the same thing and multiply the -3x with each term inside the parentheses? Notice that I drew 2 arrows, and I drew 2 of them because there are 2 terms. There are 2 different things inside the parentheses, and I'm multiplying the -3x times each of those. So if we come back up here, we can now substitute in another word for distributing. Turns out that distributing is just multiplication. I don't think I can fit it. Oh, barely. It's just multiplication, and usually it just means repeated multiplication. Okay. Really quick, I'm going to give a little example of that to help you. If that concept isn't quite making sense, think of it this way. What if I wanted to have, I wanted a donut. And I like sprinkle donuts. I wanted a donut and I wanted a cup of coffee. And I'm enjoying my donut and my cup of coffee. And then a few of you guys come in and you see me in class and say, Mr. A, I want a donut and a cup of coffee also. 4 of you walked in. And I said, sure, I'll get you guys donuts and coffee. So now I want to have 4 groups of donuts and coffee, which means I need 4 donuts and I need 4 coffees. So if we were going to mathematically work this out, we're just saying I'm going to write it below here. Then I'm going to go buy or figure out where to get 4 donuts. My yellow donut looks better than your green donut. And 4 coffees. That's the idea of the distributing going on. Notice that in the first part of the problem here, the 4 is on the outside. We're saying 4 groups of a donut and coffee. I want 4 groups of a donut and coffee. To distribute is just to rewrite and say, now I've got the 4 attached specifically to the donuts, and I've got the 4 attached specifically to the coffees, but it's the same thing. 4 groups of a donut and coffee is exactly the same as 4 donuts and 4 coffees. The distributing is just working that 4 through each part of the problem, and then once we're done, notice there's no more parentheses. All right, so let's apply that to the math. All right, I really want to get rid of some of that so we don't see it. There we go. So now we're going to multiply that negative 3x times the 4y, and we're going to get negative 12xy, just like we did before. And now we've also got a negative 7. There is a second term, so I'm going to have a second time I distribute. So now it's negative 3x times the negative 7, and a negative times this other negative is going to cancel to a positive. 3 times 7 is 21, and don't forget your x. And so now it turns out this is exactly the same as the original problem, but the negative 3x is distributed or multiplied inside of the 2 original terms. So they're equal to each other, but the second one is simplified because now the parentheses are gone, we've done the multiplication, and that negative 3x is inside of both of these terms. Both terms in the parentheses were changed. They were multiplied by a scale of negative 3x, and now that's the new simple problem. All right, let's keep going. Let me just walk that through again to show you right now. If I have a negative 5, and notice it is not a 5. It is a negative 5. Again, we've got to always attach those negatives. And I have 3 different things inside the parentheses. I've got a 3x, a negative 7y, and a 14. That tells me I'm going to distribute the negative 5 3 times. Okay? I'm going to draw 3 arrows because there's 3 terms in there. Each of those 3 are different terms. And each of those, we're saying, I want 5 negative groups of the first term, 5 negative groups of the second term, and 5 negative groups of the third term. So I'll draw 3 arrows. I'll multiply 3 times. Okay? So negative 5 times 3x, negative 15x. Negative 5 times negative 7y. 2 negatives cancel. Now, I could go here and cancel them both like we've been doing so you can see what's going on. I don't want to do that because in a minute, I'm also going to multiply that negative 5 times the 14, and we might get confused if we canceled the negative on the 5. So we're not going to do that because we don't want to get confused. So a negative times the negative, positive 35. Don't forget the y from that negative 7y. And last, negative 5 times 14, negative times a positive and negative. And I'm going to go over here and work that out because I don't want you doing it in your head, and I don't want to do it in my head either to make sure it's correct. Okay, there we go. Notice we started with 3 terms on top. So after distributing, we should still have 3 terms because we're multiplying to each of those. We should start with 3 and then we should end with 3. Whatever you start with, make sure you end with that many. Notice the negative 5 is gone. Sometimes I would see students they'd want to keep a negative 5 out front. Common mistake I would see is they'd want to keep the negative 5 out here and keep everything in parentheses. Okay, that's not the case anymore. That negative 5 disappeared. That negative 5 is inside of those three terms. Okay, the negative 5 is what made each of these guys get bigger. So the negative 5 is gone and the parentheses are gone. Okay, one more example. Here we go. 4x minus 5. Now notice, this has something in front. So the question is, what's the distributing? This is what we want to look at right here. There's a negative 5 stuck right up against a set of parentheses. This is what tells me we need to distribute. Okay, I call these parentheses parenthesis prison. Okay, everything inside of those parentheses is in parenthesis prison. The 2x and the minus 12 are stuck. If we weren't sure about what we were doing, we might try to combine like terms and put those x's together, but we can't because that 2x is stuck in parenthesis prison. Until we distribute, until we multiply that negative 5 into the parentheses, they're stuck and we can't get them out. We can't use them for anything. So we can't do that. We have to instead do our distributing to break them out so we can combine. So this negative 5 needs to distribute to the 2x and to the negative 12, and I know that it's 2 times I distribute because I see 2 terms inside the parenthesis. So negative 5 times the 2x, negative 10x, negative 5 times negative 12. If you want to here, you could cancel because that's the last time we're going to distribute. So if that helps you, we can do that. Those 2 cancel. We have 5 times 12, positive 60. Okay, we don't need parentheses anymore. They're gone. And notice the negative 5 will disappear from the problem. It's inside of those 2 terms, so it's gone. The only thing left is the 4x. We didn't use him yet. And we couldn't combine the 4x with any of the other stuff because it was locked up. Now that we've distributed, we broke everybody out of parenthesis prison, and now we can finish. Now I can combine those like terms, 4x and negative 10x. Gives us our negative 6x plus 60. There are no other like terms. We just bring it down. And there you go. Notice we did step 1, the distributing that we needed to do. And then step 2, we simplified, which really means to combine any like terms that we see. Okay. This, if you're willing to trust me here, this is something you want to be able to see and do in your sleep. Okay. This is very foundational to being able to work with expressions. And in about 2 weeks, we're going to start working on equations. And this is something you're going to use over and over and over with equations. Okay. This is an important skill. You will use it later. Invest the time. All right, so basically I'm telling you to do this, just like we did on this problem. We were distributing a negative 5, and there were 3 terms inside that we had to distribute, okay? Now, just a little practice to get you into the idea of this. Don't even solve these, okay? Just look at them. You don't even have to copy these down if you don't want to. Just look and answer this question for me. When I say what is distributing, I mean what term. So for 1, 2, 3, write down what is the value that's going to distribute, and then second, how many times is it going to distribute? I just want to get you into the habit of looking at an expression and zeroing in on the distributing that needs to happen. What are you going to distribute and how many times? Okay, you do that here. Pause, do all 3. Unpause. We'll see if you're right. Okay, first one. What are we distributing? This stupid highlighter. What are we distributing? The negative 3. Okay, that's what hopefully you're noticing. It's right up against the parentheses. And how many times? We're going to distribute that negative 3 twice. Okay, there's 2 terms in the parentheses. We're going to multiply it 2 times. Okay, next one, number 2. What are we distributing? Right here, we're distributing a 6. It's right up against the parentheses. So we're distributing the 6. I don't like the equal sign right there. That might be confusing. Okay, and how many times are we distributing it? Hopefully you're going to see 1, 2, 3 terms inside, meaning 3 arrows. We're going to distribute 3 times. Okay, and by the way, these arrows, I highly, highly, highly recommend them. I may even say require them. This is how I get kids into the habit of distributing. And if you're on a quiz and you need to distribute and you show me the arrows, I can give you points because you understand the concept, even if your actual math maybe messes something up. Okay? If there's no arrows and you have wrong answers after that, I have to guess about what you were doing. You're going to miss more points. Okay? Help me know what you're doing. It gives you more points. All right, last problem. What are we distributing? When you look at that problem, and it's way up here on the front. Okay, we're distributing 6 again. I didn't even notice that, same number. And again, how many times? 1, 2, 3. Turns out those 2 are the exact same thing. Distributing 3 times. Okay, all right, now you guys oh, no, one more thing before we do practice. Distributing a negative. Now, right here, notice how that works. Some kids, I'd say often, might want to do this. They might think that the 6x is something they have to distribute. That is not the case, okay? This negative sign changes things. The negative is what's up against the parenthesis, and that negative sign has a coefficient, or excuse me, a value associated with it. There's no variable, so we won't call it a coefficient. There is a 1. As always, the negative, or I mean the invisible 1, is attached to the negative. And when you rewrite it that way, all of a sudden, we can see there's something to distribute. It's a negative 1. So in this problem, we're distributing negative 1 to each thing inside. There's 2 terms inside, so 2 times to distribute. And all that we're distributing is the negative, okay? The 6x is just a term that's waiting to combine. We'll be waiting to combine him in just a minute with the 8x, but we can't yet because 8x is in parenthesis prism. So we're going to have to wait till we break him out. And to break him out requires that distributing, okay? So it would be negative 1 times 8x, that's just negative 8x. And then negative 1 times 12, negative 12. Now, you will see this with a subtraction sign. It's never going to happen with an addition sign because there's no point in distributing an addition sign. It doesn't change anything in the parentheses, so there's no point. But you will often see a negative sign outside the parentheses. And the idea here is notice all we're doing, we're just changing the sign of everything inside the parentheses. To distribute a negative is just to flip the sign of everything each term. That's all you do. So that's a shortcut once you get the concept. 8x will just become negative 8x. 12 just becomes negative 12. And now the negative's gone, the parentheses are gone, and we're back to our normal business. Bring down the 6x, bring down the minus 14, and now we're just combining like terms like we always would. 6 and negative 8 makes negative 2. Negative 12 and negative 14, bad guy, makes negative 26. And there we go. All right, you guys Let's do a few practice problems. Okay, simplify. If there's distributing, do it. If there's any like terms after that, do that. Okay, start with your distributing, then combine your like terms. Go. Pause it. Go. All right, let's look. Number one, we're going to distribute that -8. Two terms inside, so I'm going to distribute twice. -8 times the 3x, negative 24x. -8 times -9. Notice, remember, the sign always goes with a number. Two negatives cancel to a positive. 8 times 9 is 72. We would look to see if there's any like terms. There's not. We've got one x term and one constant term. That's it. We're done. That's as far as you can go. Number two. Okay, these guys are locked up in parenthesis prison back here, so we have to distribute before we can do anything else. I'm distributing a -3. Notice that. Two terms, so I'm going to distribute twice. -15. And then -3 times 6, -18p. Now I'll just bring down what didn't get used the first time. That 14p is just still hanging out, so we brought him down, and we'll go from there. We've got that p, and that p is a like term. Don't forget the sign. That's 14 good guys, 18 bad guys combining together will make -4p. There's no other constants, so I just bring down the -15. And there you go. All right, number 3, almost done. What do we have to distribute? Right here. Hopefully you're sharp and you saw that. There is a negative to distribute. If you want to think of that as -1, if you want to even write in the -1, go for it. It's going to distribute 3 times, and whether you think of it as a negative or a -1, either way, it's just going to flip the sign when you distribute or multiply it through. So 8n becomes -8n. 4 becomes -4. Negative times a negative on the 2m becomes +2m. And now we distributed the negative. We got rid of the parentheses. We broke everybody out of parenthesis prison. So I'll just bring down the 11m, bring down the n. And let's finish up. Look for any other m's. Yep, there's some over here. 11 and 2 is 13 m's. N's, I've got a -8n and a +n over here. And there's a 1, don't forget, that's a +1n, so -8 and 1 is -7. And we've just got that -4 left over. So there you go, we distributed, then we combine like terms. It's fully simplified. All right, guys, hope this makes it clear for you. Let me know if you have questions tomorrow. Later.